That is the graphical method. We call it graphical method. When we have two variables uh, in a scenario, when we have to choose about like two things, then we use the graphical method. So first two chapters, it will be like, the just the introductory things. Then after the third one, then we will go towards the simplex method. Uh, it will also be like, solving it using using hand. And then we will just make mathematical models and implement it into Torah. So you will learn about Torah too, and you will learn about how practically we can solve it using our mind and on paper. The course is all about some the course is all about some algorithms and heuristics. You will have certain steps. You will have to follow that, and you can solve any kind of question on that, whatever comes in your paper or in your any regular life scenario. You can convert it into a mathematical model and you can solve it by yourself. If it is not complex enough, like it has like too many variable, like maybe 10 or 11 variable, then we use software and these kind of things supports. But if you have like two or three variables, then you can easily do it on paper, and you can have an optimal solution. You listen to me? Okay. So now I will have a whiteboard, and I will write down the 7 steps. Uh, some books refer it to 5 steps. The one we are using, you know, uh, we will have like 5 steps to make a model out of a regular scenario. Let me open the whiteboard because it is taking some time. Be with me, please. It is taking some time. So yes, I'm sharing it, but it is not progressing that much. It is like halfway, and it is not showing my board so that I can, write down the steps and make an example and solve it for you so that you can see how it is solved. Okay, till then, let me introduce the subject and these kind of things just for revision purpose. Okay, till then it will be open, so we can then proceed to it. So first we will introduce the operation research, and we will study what is basically operation research. So operation research, as the name suggests, operations research. So it is a scientific approach to make decisions. We have uh, companies, factories, and setups working, making some product out of some input and working on it. So we always have to make some certain decisions. The decisions may be like how many, for example, if we are working in a big industry, you know, which is making like two or three kind of products, like it is making school bags, it is making handbags, and it is also making wallets. So if you are an industrial engineer and someone comes up to you and says, okay, I have to make a decision between these three items, which one to make and how much to make, to decrease my cost and improve my profits up to maximum level. So this is where the operation research comes into play. And it is all about making decisions about these variables, like how many products to make, which one to make, and when to make. So the field is very broad. It is like uh, from production to scheduling to healthcare and to any kind of service field. It is expanded in all the businesses, and it shows us how to operate a system under certain limitations, because the the material, time, and these kind of things, these are scarce, these are very limited, and you have to make the decisions based on the limitations, considering the conditions and limitations of these inputs. So operation research is a scientific approach to make decisions in order to operate a system which is under these kind of conditions, these kind of limitations. The conditions or the limitations, these are also called the constraints of the system. So now we will introduce a system, because we just said that it is used to make decisions in order to operate a system. So the system is basically composed of three main components. First thing is input, the second one is the process, and the third thing is output. The input may be, an idea, a raw material, or something like that. Idea may be in a service system, and raw material is based on the manufacturing system. These inputs are then processed using some processes. It may be a machine working, a human working on something, or some input, like a human working on some wood and making, some craft. So that is also kind of a process, and making some output out of it. So these three are the basic components of the system: input, process, and yes, Anwar. Yes, yes. It, but it is a manufacturing system. The in thermodynamics, you may be, studying about some engine or that kind of system, some the heat system, or some kind of system that is not making anything, but that is just only processed. But in a manufacturing setup, The system we consider here is either a manufacturing system or a service system. Just like a bank working, an educational institute. So you do not have some real product over there, but you have a product in terms of satisfaction. You have products in terms of education. You have products in terms of ideas and these kind of things. So that is actually service system. You don't make real products like something from. Yes, the market, that is also a service system. Like I am, for example, I'm hired by someone to teach him something. So that is the service system. I'm not giving you some tangible product. I'm giving you some intangible product like ideas. I'm giving you ideas how to do something, how to solve a question, for example. Now that is a service system. I'm not giving you some tangible product. I'm not giving you making you some mobile phone, or I'm not making you some wallet or anything like that. Yeah, so that is something I want to you to know, that this is the service system, and the differentiation basically is between the tangibility of the end product. If the end product is tangible, this is a manufacturing system. If the end product is not a tangible thing, you can just only feel it, or you can smell it, or you can uh, some kind of things like that. Then it is a service system. For example, hoteling, that is a service. You make the experience of people better. So that is service industry. So every system has its own capacity. For example, in a service system, I can say that the number of people working in a hotel, that is the capacity of the hotel. For example, in the manufacturing system, I can say that the number of machines working on certain thing to produce, that is the capacity of the manufacturing system. So every system has its own capacity, and you have to be inbound of that capacity to make decisions. You cannot go over that capacity. So operation research is all about thinking that how can I operate the system in an optimal way, that I do not cross the limitation of the system, but yet I am profitable, and I am making the cost even lesser. Yes, and the uh, origin uh, of the operation research, it all started with the World War II. And the basic problem, yes, World War II, one World Warning, World War II. And the problem they were facing were, you know, they could not, um, they could not calculate how much men we should move, how much food we should take to from point A to point B, and how much ammunition and oil we should, move from point A to point B in order to be effective in that area. So the British Army started to think like, what can we do to order to optimize the our weapon system. We can mobilize men, machinery, food, oil, and all of these things in a certain way that the resources we do not run by our resources, and yet we are most effective in that area. We push the army back, the enemy. So that was the idea. The problem that arose in World War II was the logistical problem. So basically, it all started with the logistical problems of the army, and they started to think, how can we optimize our strategy? Now we will come to the mathematical model. So in operation research, the very the very basic thing and the most important thing that you need to learn. You put a question yesterday that what should I learn in operation research in order to be uh, good at it and earn a good grade. So let me tell you that the thing that you need to focus on is to how to build a mathematical model. In this subject, you will be given a real-time scenario of some industry, of some company, and the teacher will ask you to make a mathematical model for this company according to the data given. Transform it into a mathematical model, process it, and make some optimal solution. And tell me what he should make, or what he should buy, or what he should supply in order to make his company more profitable or more less costly. So there are two kind of uh, mathematical models that you will come across. The first one is the maximization problem, and the other one is minimization problem. Do you know what is minimization and maximization? Okay, okay. Let me, explain it a bit, in order to, you to understand it. So first we will come to the maximization problem. The maximization problem of a company is when the profits are concerned. When we are talking about the profits, then it is a maximization problem. You need to improve the profits. You need to maximize the profits. You understand the maximization? Okay. And it also can be like a mixing problem, maximization. Like for example, you want to make a protein shake. Okay. And you want to have the maximum, protein in that shake. And you have ingredients like ingredient 1, 2, and 3. So this is also a maximization problem, that you want to improve or maximize the protein ingredient of that shake. The end result is the maximized ingredient of protein in that shake. So you will have to play with the three variables. Like for example, you are given like three things. For example, first thing you are given is mushroom. The second one given is some fruit, and the third one is like some salad or something. So you will have to play with these three things and make a protein shake out of it, which is uh, you know maximum in protein ingredient. So that is also a maximization problem. Other thing that can be a maximization problem is for example, the currency exchange problem. You want to increase the output of it. You want to maximize the output of the currency you exchange in different currencies. For example, you have like Kuwaiti dinars, like 1,000 Kuwaiti dinars you have, okay, and you have like five currencies in your options to play with, and you exchange it using different methods, and the end result you want is to improve the value of the 1,000 Kuwaiti dinars to somewhat 1,400. So that is also a maximization problem, and is also a service problem. You understand the maximization? Okay, now we come to the minimization problem. Minimization is all about when when we are concerned with the cost of the company or the cost of the process. When wherever there is cost that is coming up to you in some question, it is a minimization problem. You understand that this is a minimization problem, and I have to minimize the cost of it. The yes, re- reduce it, and there are two things like in operation research. The first one is the feasible solution, and the other thing is the optimal solution. Feasible and optimal solution. Feasible is something like it is okay to produce this much, or it is okay to to manufacture this much of wallets or laptops or bags, but it is not maximum profitable. It is also called suboptimal. For example, you have like your cost for 1 month, cost for 1 month living in Kuwait is like, for example, 800 dinars. Okay, now if you have 800 dinars, you can easily live for 1 month over there. Okay, if you have 850, you can also live very gracefully over there. But if you have 2,020 dinars, then you can luxuriously live there. So the 800 quantity, the 850 dinars quantity, that is suboptimal, that is feasible. Okay, you can have it and you can live over there. But if you have 2,000, the 2,000 thing is optimal. This is the maximum. Optimal is something that is maximum under some limitations. You understand the difference between feasible and the optimal? Yes. Yes, it is the maximum. Yeah, it is the best one. It is the best quantity that you can achieve. So in maximum and in minimum, the idea will change. For example, yeah, so the feasible solution actually satisfies all the constraints. It is under the limits of the system. But the optimal optimal is also, satisfying all the constraints. But in addition to being the feasible, it is the best outcome. So in maximization problem, it is the maximum, and at a minimization problem, it is the minimum value of the objective function. Yes, yes, I will share the whiteboard. So the optimal solution is the best yield. So it either be maximum in the maximization problem or a minimum in the minimization problem. Okay. So now we will move to the solving the OR problems or any model. So a mathematical model in operation research have actually three main parts. The first one is the objective function. Number second is the decision variables. And the third one is the limitations or constraints of the system. So the objective function is actually the function of the system that defines it, like uh, whether it is a maximization problem or the minimization problem. So objective function defines the system. Then comes the decision variables. The decision variables are the variables that are in our control. How much to produce or how much to supply. These are the variables that is in our control. We control it, and we move their quantities to see how the results are changing. For example, we have like two products in a company. The first product is I will I will open my camera and write it on the paper so you can see it. Because whiteboard is again taking time and Can you see it? Okay, it is better now, or I should, have some. It's better. I will put some another light also so that the experience is good. Okay, so every model has three things. Okay, I will, uh, write a model and I will explain the different parts of it into a mathematical model. So you will understand how it is, you know, how it is written and what are the parts of it. Okay, for example, I have a maximization function and it says maximize z, and it is equal to 300 into x1 plus 350 into x2 plus 900 into x3. Now, when we say that maximize z, it means that it is the maximization problem. And these constants or coefficients, these represents the profits per unit. Okay. For example, x1 is mobile phone, x2 is laptop that we are making, and x3 is tablets that we are making. So selling each unit of mobile phone, it yield a profit of $300 per unit, while selling a laptop, while X3, which is tablet, it yields 900 per unit. Okay, so this is objective function. Maximize z is equal to 300 x1 plus 350 x2 plus 900 into x3. This thing is called objective function. Now, how we write it? We write it into two main parts actually. The first thing is the objective function. For example, ax1 plus b into x2 plus c into x3. And then we write subject to, and then we write the constraints of the system. For example, x1 must be less than or equal to b, or x2 must be greater than or equal to c, and x1, x2 must be greater than or equal to 0. So these are the constraints of the system, you know. So this system, the solution that we need to find, that must, obey, or they must, confirm these limitations. They must be under these limitations. This is very important in operation research, and this is how It is AX1. It is not 9x. This is AX1 plus DX2. DX2 plus CX3. Yes. And this can be any number. This A, B, and C. This can be any number. This is just a generalized form of how we can write the mathematical model in operation research. Yeah, so this is how we write the mathematical model uh, in operation research. First, we write the objective function, then we write subject to, because these are the conditions beneath the subject to, we write the conditions of the system that we need to follow, that we must obey. I will give you, a real-time example of it. Then you will understand. This is generalized form. So I will transform this generalized form into something real, so you can understand it. Okay. Okay. Let me take an example from the end of the chapter, so that so for example, we have a manufacturing facility that is making two products, X1, which is a bag, and X2, which is a wallet. Now X1 represents a unit of bag and X2 represents a unit of wallet that the company is making. Now each unit of bag yields profit of $5, while each unit of wallet yield profit of $2. Okay. The production manager says that we cannot make greater than 300 bags, and we cannot make more than 900 wallets. So how much wallets and bags to be made to make maximum profit. Now I will, try to convert this scenario that production manager has given to us into a mathematical model. So first of all, we will, identify the decision variables. So the decision variables here are x1, which represents a unit of bag, and x2, which represents a unit of wallet. These are the decision variables. Okay. Now we see that the profits are of concern here. So it is a maximization problem. Do you hear me, Yusuf? Okay. Okay. So as we see that this is the maximization problem and the profit is of concern, we see that you should the very first thing that you need to know is you have to read the scenario, how to get the scenario and translate it into a mathematical model. That is the most important thing in operation research. If you can do it, you can solve any kind of question. You see, now we will make the objective function out of these decision variables and the above statement. So the decision variables are x1 and x2, and the objective function will be, can you give me your input for the objective function? Like what should be the objective function? A unit of bake yields a $5 profit while the wallet yields $2. It is quite simple. First of all, you need to mention it like it is maximization or minimization. So what should I write? Yes, maxi. Maxi is equal to, now how much profit the bag is yielding per unit. Five $5. $5. Yes. So we will use this as the what is it called, the constant for the variable x1. So we will write it as maximum z is equal to 5 into x1 plus, and what is the wallet yield? It is yielding $2 per unit. So this is the objective function for this problem. This is the profit for each bag, and this is the profit for each wallet. And we have x1 representing bag and x2 representing wallet. So we will use the sum product formula. Sum product. It is a formula which when we have like um, quantities and variables in one correspondence. Like we have five variables and we have five quantities for each of the variable, one for each. So we just multiply the quantity with the the corresponding variable and add it to the product of the second quantity multiplied by the second variable plus third one, and similarly going up to 5, 6, 7, and up to hundreds of variables. It does not depend like you have 10 or 5. You can go up to 100 and thousands of it if you have. Let me explain it to you like this. For example, x1 is a variable, and the quantity the quantity or the profit or the cost for x1 is like, for example, 3 x2, and the quantity for this or the profit or the you can say that the cost for this is 2 x3, and the cost or the quantity is 1 x4. The cost and or quantity or the profit for x4 is, for example, 5. So now you have four variables and we have four different kind of quantities, one for each of the variable. You see? Now we will multiply each of the quantity with its variable and add it to the product of the other, and add it to the product of the third one, and add it to the product of the fourth one. So it will come into this shape, like for example 3x1 plus 2x2 plus 1x3 plus 5x4. So this is the sum product. What? We have 5 for x4. This is yes, this is another example. This is not related to this thing. I just explained the sum product using this example. This is not related to the other. Okay. So now when we define the objective function, then after the objective function, for example, we have the objective function of 5x1 plus 2x2. Then we write subject to. Now we will use the limitations or the constraints of the system. Now the first constraint that the production manager has given us is that we cannot make more than 300 bags. So how we will write it in the constraint section? We cannot make more than 300 bags. And the variable for bags is x1. Yes, it must be less than or equal to 300, because we cannot make more than 300 bags. So x1 must be less than or equal to 300. Now this is a limitation of the system constraint. And our feasible solution or optimal solution that must obey this one, like x1 must be less than 300. It may be smaller than 300, you know. Now I will explain the feasible and optimal also, using this example. Okay, you will understand it now. If there is some problem in the understanding feasible and optimal, you will understand it. Okay. Okay. So now for the second one, the production manager has given a second constraint to us. And he says that we cannot make more than 900 wallets. So wallets are represented by x2. And it says that wallets must be less than or equal to 900. So this is the second constraint of the system. Now, what will be the third constraint, which is like, universal for all the linear programming problems. The third constraint will be non-negativity constraint, that x1, x2 must be greater than or equal to 0. You must produce something. It means that you must produce something. It cannot be less than 0, either x1, the number of bags, or x2, the number of wallets. Now, this is the complete LP model for the scenario that was given to us by the production manager. We transformed that information into a mathematical model, and we will solve it, the mathematical model, in order to find the optimal quantities of x1 and x2 to yield the maximum profit. Now I will explain the feasible and the optimal solutions to it. Can I go forward, or you want to ask something? Okay, okay. So now, for example, we are given that x1 is equal to we have, like, for example, three options. Okay, the number one option is x1 is equal to 100 and x2 is equal to 300. The second option is x1 is equal to 400 and x2 is equal to 700. The third option is x1 is equal to 250 while x2 is equal to 750. Now we will use these three options to understand what is feasible among these and what is optimal among these. Now, this is the same problem, but I just, added this thing, like we have three options, three solutions to it. And now we will test these three solutions to understand the difference between a feasible one and non-feasible one and the optimal one. Okay, so now maximum z, we know that it is equal to 5x1 plus 2x2. Now, using option 1, x1 is equal to 100 and x2 is equal to 300. Now putting the value of x1 is equal to 100 and 200 into this function above, we see that z is equal to 5 into 100 plus 2 into 300. It is 500 plus 600. So the total profit is $1,100 for option 1. Now using option 2, x1 is equal to 400 and x2 is equal to 700. Now using option 2, we have the value of z is equal to 5 into 400 plus 2 into 700, which is equal to 2000 plus 1400 is equal to $3,400 for option 2. Now for option 3, we have x1 is equal to 250 and x2 is equal to 750. Now z, an objective function, it is equal to 5 into 250 plus 2 into 750. Now 5 into 250, it comes like 1250 plus 1500, which is equal to like $2,750 for option 3. Now, which one is the maximum? The first one is yielding $1,100, second one is yielding $3,400, and the third one is yielding $2,750. The second one is maximum, but there is a conflict. There is a conflict in the constraints. We see that x1 in the second option is equal to 400, but in the mathematical model, we know that it cannot be greater than 300. So how we define the feasible and optimal solution? That it must satisfy the constraints. And in second option, x1 is equal to 400, it does not satisfy the constraint number 1. So we will straight away reject the option 2. It is not feasible solution. It is not a feasible solution because it is not satisfying the constraint number 1, which is that bags must be less than or equal to 300. You see? I just picked it as a solution. I just to make you understand between the feasible, non-feasible, and optimal solution. So I picked these 3 solutions. Yes, yes, it's from my choice, but just to let you understand, like the difference between a feasible, non-feasible. How will you know about that this solution is not feasible, this is feasible, and this is the optimal one. Some of the question in some of the questions you will be given like these kind of solutions, and you will be given the objective function, the constraints, and you will be given solutions, and you will be questioned about to check these solutions and tell me which one is feasible, which one is not feasible, and which one is optimal one. So you need to understand these kind of um, methods to define which one is feasible, non-feasible, and the optimal one. So the second option, in which the bags are 400, so it is not feasible because it is contradicting the constraint number 1. And a feasible solution, an optimal solution must not contradict any of the constraints. It must satisfy all the constraints. Now we will come to the feasible and optimal solution. Now we see that in option 1, we have x1 is equal to 100 and x2 is equal to 300. So x1 is less than or equal to 300. So x1 is equal to 100. It means that it is satisfying the constraint number 1. And x2 is equal to 300. It is also satisfying the constraint number 2. It means that the solution 1, that x1 is equal to 100 and x2 is equal to 300, it is a feasible solution. And it is $1,100. So it is feasible, but it is not optimal. And why it is not optimal? It is not optimal because we have option 3 in which we have x1 is equal to 250 and x2 is equal to 750 wallets, and both of them are satisfying the constraints. Bags are 250, which is less than 300, and wallets are 750, which are less than 900. So both of them are satisfying the constraints, yet it is yielding $2,750 of profit, which is the maximum of all. So it is basically the optimal one. Now you understand the difference between the feasible, non-feasible, and optimal one. Okay, so this was just for you to understand. Inshallah, I will make some videos, uh, examples for you, and I will post it to you via Josefa. Okay, and you can see it. And yes, yes, I can make live videos, but in the night it is because here in Pakistan there is like light problem. So in the night I had like an hour and a half delay because of the light situation. So in the day it is like quite okay to because yes, yes. Okay, Josefa will send you the remit or the mm, the wise account or anything that